Okay. Last time we have started the topic, no, not really started. We were going through the topic of travel time. You are Zainab Ali. So in the last lecture we did two examples for travel time studies. Both of them included calculation of sample size. Okay. In one example the data was given directly. In the other example we calculated the mean and standard deviation and so on and so forth. Okay. When we started this topic I mentioned that we can use travel time data to make travel time contour maps. Okay. This is a travel time contour map. Okay. And you have heard about contour maps in which course? Survey. Okay. So, like in a contour map, the lines show same elevation. Okay. In a surveying contour map, the lines show same elevation. In a travel time contour map, the lines show same travel time. Okay. Like surveying contour map, we need a benchmark, a reference point, a 0 point. Same thing here. Okay. So these lines are showing same travel time from the control point. This is my control point. Okay. Up till now, we have talked about doing travel time studies on a highway. This is not one highway. You can see it's the whole area, right? This is the whole region, the whole area. Okay. What is the application of travel time contour map? They help you find out the catchment area of a facility, okay, of your control point. What is the catchment area of your control point? Okay, and where did you hear about catchment area? Any question? No? Water? Sure? Okay. So the catchment area means basically the area from which you can expect the water to come, right? So the catchment area for travel time are the travelers, or the area from which you can expect the travelers to come. Okay? When you decide about your trip, okay, like regular trip, not a trip to Europe, not that trip, regular routine trips, okay, for medical, for bank, for shopping, okay, you always keep in mind which one will be having the least travel time, right? Which one will be the closest one, right? So the closest facilities to you are more attractive to you, right? The facilities which are closest to you, they are more, okay, not attractive, convenient for you, right? Okay, they are more convenient for you, okay? So there is a higher chance that you will go to this point than any other point, right? Because it's closer to you, right? You want to pray, you want to do shopping, you want to go for a bank or a clinic. The things which are near you, they have more chances that you will go to them, right? Okay. So the same rule applies here. People who are nearer to the control point, they have more chances of coming here, right? Okay. So if it's an airport, then people who are near to the airport are more likely to come. If it's a hospital, then people who are nearer are more likely to come. Okay. So for example, this contour line is for 15 minutes travel time. So all these points are 15 minutes from this point. Okay. And all these points are 30 minutes from this point. Okay. From which area people are more likely to come? 15 minutes or 30 minutes? 15, right? Okay. Wake up. Okay. Clear? Okay. So this is the idea of the travel time contour map. This is a time-space diagram which is drawn for a particular vehicle. Okay, so you observe a vehicle going from start to end, you record the distance and you record the time. And then you plot distance on the x-axis, time on the y-axis. Okay, and distance upon time gives you what? Speed. Okay, so if you take the slope, you can get the speed as well. Okay, right? And what else can you see from this diagram? You can see this is my line. This is the path of the vehicle. This is how the vehicle has moved. So at this time it was here. At 30 minutes it is here. 60 minutes here and so on. Okay. Now you can see at some point the line goes up. It doesn't go forward, it just goes up. So up means what? It's delay, right? The time is moving up, the distance is not going forward. Okay. So you can find out how much is the delay at each point. The delay at this point, this much. Here, this much, and so on. Clear? Okay. Then you see another line here which they are calling as average speed. Okay. So the speed of the vehicle is different at all the points, right? The slope is changing, you can see. Okay. At some point goes 0 as well. Okay. So how do you find out the average speed? You take total distance upon total time. This is the average speed. Total distance upon total time. From here, from the start to the end, total. For both axes. Okay. And then you do the ratio and you get the speed. Okay. So I told you speed is what? The slope, right? Distance upon time. Speed is the slope. So when you know the average speed, you know the slope now. So this line is according to the slope of average speed. Got it? Clear? Okay. Yeah, and this type of diagram is driven for different routes. Okay, like from place A to place B, the whole route. Okay, so it's not for one highway or not for one intersection, it's for the whole route. Clear? Okay. Now we go towards delay studies. Now up till now we have talked about delay, right? I showed you the diagram, the delay was there, right? Okay. But that delay is in the segment, in the highway itself. Okay. So you can measure it using the stopwatch. The car is stopped, it's delay. Okay. But on intersection you cannot do it. Because on intersection you sometimes stop even without a traffic jam, right? Okay. You come to the intersection, you may have to stop even if there is nobody in front of you, right? Okay, because maybe there is somebody crossing, or the signal is red, or there is a stop sign, and you know how to read. Okay. So on intersection, delay is not so simple that I keep a stopwatch whenever the car stops, I will take it as delay. Okay. So intersection delay studies can be done for any types of intersection. We will discuss two types of intersections here. One is signal, the other one is roundabout. Okay, but there are other types of intersections which I mentioned here. For the intersection delay studies, we find out a specific type of delay which is called as control delay. Okay, control delay. The delay which we talked about previously was stop delay, right? Car stops delay. But control delay is more than that. Control delay includes slowing down of the vehicle as well. Okay? Before stopping you slow down, right? Okay? So that slowing down is also part of control delay. Clear? And when you start moving, you will not get back to your same speed instantly, right? Like I start moving and now I'm moving 80 kilometers per hour. It doesn't happen that way, right? So you will take time to go to your same speed as well, the initial speed. Okay. This is also part of control delay. The control delay has three parts: deceleration, slowing down, stopping, and acceleration back to the normal speed. Okay. The word they are using here for normal is ambient. Ambient means the normal for that location. Clear? Okay. So control delay has three things: slowing down, stopping, and acceleration. Clear? Okay. We said we will discuss two types of intersection, right? Signals and roundabouts. Okay, we are starting with the signal. The procedure to calculate manually the delay of the signal is given in Highway Capacity Manual of 2000, and according to this procedure we need two people. Okay, we need two people. One of them we like, one of them we don't like. Okay, you will know about Okay, but we only write one of them. Keep it in mind. Now, before you do the delay study, we have to, or in addition to the delay study, we have to take care of other things as well. Okay. First of all, the free flow speed. For the direction in which you are doing the delay study, find out its free flow speed. Okay. Can I have free flow speed on the intersection? Abdurrahman. Whatever. What did I ask? Yes.
No, Ramadan. Yeah.
You can have free flow speed from Ramadan?
No. I think even you, Victoria, don't know. I say and what you ask.
No. I. Yes.
In the intersection, it can be. Can be.
Can or cannot?
Can.
Can. Okay. There is a very special case in which you can get the free flow speed directly on the intersection. Okay, and that is special case for signals again. And that special case is when a car comes to the intersection without any cue and the signal is green. Okay, this is the only case in which you can see the free flow speed on the intersection. Okay, if the signal is green but there are already 3 cars in the queue, you still have to wait for them, right? Okay, so the only special case in which you can get the free flow speed directly on the intersection for signals is coming to the intersection without any cue with the signal being green. Okay, so now you can imagine maybe in half an hour you may have 4 or 5 cases like this. Okay, so your speed data will be acquired very slowly. Okay, to make this process faster, you can go slightly before the intersection. Okay, how much before? There is no limit, but you have to see that at which point the car is still driving at normal speed. When you are reaching near the intersection, you start to slow down, right?
Yes.
So now you have to observe what is that point. You have to go before that point, behind that point. Okay? So at that point you can get the free flow speed. Okay? And just keep in mind the studies we do for free flow speed is called speed studies. Okay? Okay, so the first thing you need to find out is the free flow speed. Okay, you must find out the free flow speed, either under intersection or before that. Okay. Then before you start the signal, before you start the study, you have to take care of 2 things. Okay, and both of them are related to each other. You have to make sure that the queue on the signal is not too long. If it is too long, that means your measurement will not be accurate. Okay. Now remember, we are measuring control delay. Okay, control delay. And what do we have at the intersection? We have a signal. Okay, so I am trying to find the delay because of the signal, the control of the signal. If the queue is too long, this will not be because of the signal. The delay will not be because of the signal. Got it? Okay. So you have to make sure that queue is not too long. How much is too long? This much. Okay. If the queue is longer than that, we should avoid doing the study in that time period. Clear? Okay. Another indication of the same thing, that we have an overflow. Okay. Overflow is also indication that the queue is too long. When the queue is too long, what happens? You come towards the intersection, the signal was green. But then, if you are coming from very far, the signal will become red. This is called as overflow. So you were waiting for the green happened, but you still did not cross. Okay, because of the queue. So both these conditions are saying that the queue should not be too long. For your study, the queue should not be too long. And how do I know if this is too long? You have 2 criteria here. The first criteria is you actually see how many cars are in the queue. There are more than 20, it's too long. Okay, and the second criteria is if you see cars are coming during green, but before they cross, the signal becomes red. Okay, so this is called as overflow, and this is also indication the queue is very long. Clear? Okay. So I said we have how many observers? How many people? Two. And how many we like? One. We agree, right? We like one. Okay. So this is the one we don't like. He's the one we don't like. Okay? You can give him a name. Don't tell me this. Think about it. Okay? So this guy is counting how many vehicles are in the queue. Okay? So when he starts the survey, he counts how many vehicles are in the queue. Then he will wait. He will wait for a few seconds. How many seconds? Between 10 and 20. You will give him a number between 10 and 20. So he will wait for these many seconds and do the counting again. And then wait for the same time, count again. Got it? Waiting and counting. Okay? Now, this time which you will give to that guy to wait, okay, this interval should be integral divisor of the cycle length. Okay, you are more familiar with the opposite term. Cycle length should be a multiple of this interval. The cycle length should be a multiple of this interval. What is the cycle length? Cycle length is the total time of the signal. The full time of the signal is called as one cycle. Okay, so signal starts with red, then it will become what? Blue, huh? Yellow? Blue. He's thinking.
Blue.
What did I say?
blue.
You will write blue, I will get 0. Don't worry. Okay. So it becomes yellow and then?
blue. Green.
We both get 0. Very good. Okay, green and then yellow, right? Okay. When the yellow finishes, the last one, so the red will start, right? So you went from the first red to the second red, right? This is called one cycle. Okay? This is called one cycle. The signal finishes everything one time. It's called one cycle. Okay? And we said the cycle length should be a multiple of the interval you are giving that guy. Okay? So let's say the cycle takes 60 seconds. Okay? 60 seconds. And you tell him that you can do the counting after 10 seconds. Okay? Is cycle length 60 seconds a multiple of 10? Is 60 a multiple of 10?
Yes.
Yes. Okay. Let us increase the interval. We say, okay, you can count after every 11 seconds. Is 11 a multiple of 60? Sorry, a 60 multiple of 11? No. So 11 seconds cannot be given. Okay. Can I make it 12 seconds?
Yeah.
I can. Okay. 60 also multiple of 12 as well. Clear? Okay. So he is waiting for the interval which you will give him. The interval should be between 10 and 20, and the cycle length should be a multiple of that. Clear? Okay. Now he is counting the queue, right? He is counting the vehicles in the queue. Okay. Now queue can be stopped. Queue can be moving. You can be standing in a queue, or you can be moving in a queue, right? Okay. We have done that in the school, right? Okay. They ask you to move in a queue, right? Move in a line. Okay. So the line is what? The queue. Okay. So how will he say that this vehicle is in the queue and this one is not? Okay. The rule is very simple. If the vehicle is going straight, if it is after the stop line, it's not in the queue. If it is before the stop line, it is in the queue. Okay? He cannot say that, okay, this vehicle was moving, so it's not in the queue. No, it's moving, but it's part of the line. Okay? If the vehicle is going straight and it is behind the stop line, it's in the queue. Okay? Yeah? So this is for straight. For turning, until the vehicle reaches the other side, it is in the queue for turning. Okay, for a stop line, sorry, for straight, the stop line is the indicator. For turning, the vehicle has to reach the other side. So I'm making a left turn, I'm in the intersection now. I'm in the queue. Okay, when I clear the intersection, go to the other side, I'm out of the queue. So he will not count me. Okay, so he will count every vehicle which is going straight behind the stop line and every vehicle which is turning until it reaches the other side. Clear? Okay. Okay. Now one more thing which is the end of the survey, end of the study for this guy. There will be a time given to this guy when he is supposed to finish. Okay? But we said we don't like him. Okay? So what do? We tell him, okay, when you are finishing and there are vehicles in the queue, let's say there are 2 vehicles in the queue, you will continue this study until these 2 vehicles leave. Okay? So at 10 minutes he is supposed to finish. But at the end of 10 minutes there are 3 vehicles in the queue. And those 3 guys are your friends. You told them, just go there and stop. Don't go anywhere for half an hour. So until these 3 guys leave, he will not finish the study. Clear? Okay? Now we go towards the other guy. This one we like. Okay? So he is doing a very simple job. A car comes, he has 2 columns. Or he is noting down 2 things. A vehicle comes, he will add 1. Okay? He will add 1 in the vehicles which are coming. If the vehicle stops, he will add 1 in the other column. Add 1 in the other value. So he is taking 2 values. How many vehicles are coming and how many vehicles are stopping. Alright? There is no time interval for him. There is no integral, multiple and anything. Okay? Whenever vehicle comes, he will come and his time finishes when the survey is done. 10 minutes means 10 minutes. He doesn't have to wait for these vehicles to go as well. Clear? Okay? So, now keep in mind, 2 guys, one is taking the queue, the other one is taking vehicles arrived and stopped. Before you start the study, find out the free flow speed and make sure the queue is not too long. Clear? Okay, these are the equations used for finding out the delay for signals. The first equation gives you how much time the vehicle is spending in the queue. TQ, time in queue delay. Okay, how much time the vehicle is spending in the queue. I is the interval you gave to the first observer. The time for he was waiting. Okay, between 10-20 seconds, and the cycle should be multiple of this and so on. Okay, so the waiting time for observer 1 is IS. Okay, he will take many observations, right? He is waiting and taking the number. He is waiting and taking the number, right? So you will have many numbers. You add these numbers, that will be summation VIQ. Vehicles in the queue. Okay, so vehicles in the queue, VIQ, and you do the summation for all the values from coming from the observer 1. Okay, then we have VT. VT is the total number of vehicles which come. Okay, and who is taking this number? The second one. Okay, and 0.9 is 0.9. Okay, don't ask me in the exam where is 0.9. It's in the equation. Okay. Then the second equation is vehicle stopped per lane per cycle. Okay, vehicle stopped per lane per cycle. So you take vehicle stopped from observer 2, divide by number of lanes, divide by number of cycles. Okay, number of cycles in your study. When you did the study, how many times the cycle finished? You have to keep a count. Okay, how do we do that? We will come back to it. Okay, the next one is fraction of vehicles stopped. From the total, how many vehicles stopped? So stopped upon total. Okay, and both values are from observer number 2. Okay, the last equation, this will give us the final delay, control delay, D. Okay, so we have TQ, time into delay, we calculated it. Okay, we have fraction of vehicle stop, total upon, sorry, stop upon total, it was there. And the last thing is the correction factor. For the correction factor, I need the table. In the table, you can see we are using free flow speed. This is where we need it. This is why I said you have to find out the free flow speed. Okay? And vehicle stop per lane per cycle. We did it in the last slide. Okay? You take the correction factor from here, put it in the equation, and you get the control delay. This is a sheet, okay, which is basically from observer number 1, the one who is taking the delay, the vehicle in the queue. Okay, so some basic information on the top. Then how many lanes you have, the interval you gave to observer number 1 for taking the vehicle in the queue, total and stop. So observer number 2 will come and he will fill the values after the study is finished. Okay, so total number of vehicles and vehicle stopped are coming from observer number 2 after the study is finished. Okay, and cycle length, again you have to note it down. Okay, cycle means what? Right to right. Okay, fine. Then how do you note down the numbers? Okay, so you will write the time when you started the survey. Okay, so when you started the survey, this is cycle number 1, right? Cycle number 1. Okay, let's say the cycle is 60 seconds and your interval is 10 seconds. 60 seconds and you are taking observation after every 10 seconds. So in one cycle, how many observations you will have? How many?
60 seconds.
60 seconds.
Yes.
And you are taking observation after every 10 seconds. 6, right? It was simple, right? But you don't pay attention until I ask. Right? And you don't wake up as well until I ask. I should have like all exams and quizzes in the morning. Especially at 2 p.m. Okay. So you will have 6. After 6, the second cycle will start. 60 seconds will finish, you will be in the second cycle. So cycle number 1, all readings here. Cycle number 2, all readings here, and so on and so forth. Like this. Okay, so you can see the time, you can see the cycle number, and then you can see the observations as well. Okay, now the total cycle is how much? You can see it here, cycle number 1, cycle number 2, right? How much time passed? 1 second, very good. 1 minute. When you are sleeping, it's 1 second, yes. But 1 minute, okay? 60 seconds, okay? How many observations? 1, 2, 3. In 60 seconds, 3 observations, right? So how much is the interval? 20. Clear? Okay. Then these are the 2 values from observer number 2. Okay. And this is the free flow speed, they have taken it. Okay. Summation VIQ, summation of what? This whole table. Okay, all these values. Okay. They have already done the summation for each column. If you do 40 plus 50 plus 42, you will get this. Okay, or you do all of them one by one, you will get the same answer. Okay. Okay. For the same intersection on which this data is taken, these values are also available. Okay, they are the same values. Total cycle length, as I said, 60 seconds. Interval is 20 seconds. We have to find out the control delay for this case. Okay, so take out your phones or calculators or whatever you want to use. The first thing I will calculate is time in queue delay. So that is the interval is 20 multiplied by VIQ is 132 divided by the total is 120 multiplied by 0.9, which is the constant.
19.8.
This is average delay for each vehicle, average time for each vehicle, okay? Average time for each vehicle. Okay, next thing is vehicles stopped per lane per cycle. How many vehicles stopped? 75. Okay, we have 2 lanes, you can see it in the question, 2 lanes. Okay, for the number of cycles, I will go back here, you see the number of cycles in the second column. That's why we are putting readings or observations in different lines, so we can count the cycles. Okay, so how many cycles? 10. How much is that? 3.75. Okay, this is vehicles per lane per cycle. Vehicles per lane per cycle. Okay, then we have fraction of vehicles stopped, which is vehicles stopped upon this total. How much? 0.625. Okay, the next thing is the control delay. Control delay was timing queue delay 19.8 plus fraction of vehicles stopped 0.625 multiplied by the correction factor. Okay, the correction factor comes from the table. Okay, so what do we have in the table? First of all, the free flow speed. The free flow speed is less than 37. So the first row. Okay, this one is vehicle stop per lane per cycle, which is 3.75. 3.75 is less than 7. So first column. Correction factor is 5. 3.92. 3.95, sure. I'm doing 19.8 something. Okay. Sorry? 22.
So at this point, they use cell phone.
Clear? Clear? Okay. Clear, both of you? Clear? Okay. Now you can see here, how many vehicles in the queue? 132. How many total? How is it possible? Huh? Clear? Yes, how is this possible? 120 is total. Then how can Q have 132?
Not all the vehicle walks.
Huh?
Not all
Now
the
keep in mind, we said you should start the study when there is no overflow. So you cannot say they were already there. And we said what? We don't like the first guy, right? So you cannot finish the study until all of them leave. Okay, so the number should have matched. But it's not matching because he is counting vehicles in the queue, whether he counted them before or not. Okay, so maybe the signal timing is 30 seconds, let's say. The red is 30 seconds. So in 20 seconds, he will find some vehicles which are already there. He's doing after 20 seconds, right? So maybe the signal was red, after 20 seconds it is still red. So he will count that vehicle again, which was already there. Okay, so there is multiple counting for this guy, but not for the other guy. Okay, this is like a practice problem. The only additional thing you have to do is the summation. That's it. Okay, everything else is the same. Clear? Huh? Any questions? Okay, the next will be the roundabout, which we will do next time. Okay, thank you.